In this lesson, we will explain what Security Information and Event Management, SIEM, is, and how it has evolved over time. Introduced in 2005, SIEM analyzes security alerts in real time. Fundamentally, SIEMs do three things. 1. Collect, normalize, and store log events and alerts from the organization's network and security devices, servers, databases, applications, and endpoints in a secure central location. SIEM collects information not only from physical devices, but also virtual devices both on-premises and in the cloud. Investigators had determined that logging into every system to check for relevant log events was increasingly impossible. Also, if your logs were not secure, you had no guarantee that an attacker hadn't just deleted the entries to hide their activities. 2. Run advanced analytics on the data, both in real time and across historical data, to identify potential security incidents that should be investigated by a human. The potential incidents are prioritized by risk, severity, and impact. Over time, these security analytics have grown from employing simple cross-correlation rules to monitoring for user behavioral anomalies, watching for known indicators of compromise, IOC, and applying sophisticated machine learning models. 3. Prove that all of the security controls under the purview of the SIEM are in place and effective. While maintaining security for its own sake should drive security requirements and appropriate level of investment, in reality, for many organizations, the primary driver for purchasing SIEM has been regulatory compliance. The first 2 decades of the 21st century have seen a deluge of new compliance requirements, both legislative and industry-sponsored. Some examples are the Payment Card Industry, PCI Standard, the Sarbanes-Oxley Act of 2002, the Health Insurance Portability and Accountability Act, HIPAA, and the General Data Protection Regulation, GDPR, in 2018. Businesses, hospitals, and other organizations ignore compliance at their peril, and violators can incur punitive fines. As cyber attacks became more sophisticated and stealthy, demands for information about a cyber attack, its characteristics, purpose, and the extent of network penetration grew more urgent. Another alarming fact was that security teams very often did not discover breaches until many months after they had occurred. And then it was more often discovered by a third party than by internal security. IT security needed a holistic picture of network activity, and the real-time data collected by SIEM filled this need. In the second stage of development, SIEM vendors added threat detection capabilities with built-in threat intelligence, historical and real-time analytics, and user and entity behavior analytics, UEBA. And more recently, machine learning has become a part of SIEM's toolset and is particularly needed when sifting through big data. Another issue that hindered SIEM's greater acceptance by organizations was the effort involved to set up, integrate, and use it. The technology was complex and difficult to tune. It was difficult to identify attacks. And it demanded a high level of skill on the part of the user to know what they were looking for. For all its capabilities, SIEM was not a set-it-and-forget-it technology. The situation was exacerbated by 2 other facts. 1, IT security suffers from an insufficient number of qualified professionals. And 2, the siloed approach used in typical network operations centers, NOCs, and security operations centers, SOCs, increases complexity and causes a lack of network visibility. An environment composed of multi-vendor, single-point solutions with different operating systems, patch cycles, protocols, and logic worked counter to interoperability and simplification. The result was greater demand on sparse IT resources, increased chance of human error, and reduced network security visibility. So while SIEM made great strides moving from an information platform to a threat intelligence center, it remained hamstrung by both external and internal limitations. The systemic shortage of trained personnel was the impetus for more automation and machine learning in later SIEM devices. Artificial intelligence more quickly detects trends and patterns in enormous payloads of data than even the cleverest human can. Moreover, time and accuracy are gained by configuring SIEM to automatically respond and remediate. Recent developments in SIEM have also integrated NOC and SOC, thereby establishing SIEM as the nerve center of all network and security operations. So, from a single pane of glass, IT security gains visibility into the entire network. SIEM simplifies deployment and integration by way of a self-learning, real-time asset discovery and device configuration engine. This tool establishes an inventory of network devices, applications, users, and business services. It then builds a topology showing how each object is interconnected, thereby establishing a baseline of normal network behavior. By determining normalcy, and with the aid of machine learning, abnormal behavior can alert analysts of a cyber attack, which can then be stopped before a breach occurs. Within a couple of decades, SIEM has evolved from an information platform to a threat intelligence center to a fully integrated and automated center for security and network operations. The Fortinet SIEM product is named FortiSIEM and encompasses all of these features, plus others. Thank you for your time, and please remember to take the quiz that follows this lesson.